Hey everyone, Gilberto from Snowflake here. Today I'm going to be showing you how to programmatically manage Snowpark Container Services using Snowflake's new Python APIs. And the cool thing about today's demo is I'm going to be using Snowflake notebooks, which are currently in private preview, to be able to walk through each part of the demo and explain what I'm doing step by step. Now, before we get into the details, I figure it's a good time to give you a primer on exactly what Snowflake Python APIs are and how they differ from Snowflake's connector for Python and also Snowpark for Python. Let's get into it. All right, so if you're using Python with Snowflake today, there's a good chance that you're probably using the Snowflake connector for Python. Now, the Snowflake connector for Python allows you to execute the SQL queries that you might typically run in your Snowflake environment directly from your Python-based client code. So once you've installed it and connected, you can start using it, and you can do things like create databases, schemas, warehouses, all sorts of Snowflake objects. You can load data, query data. You can do all sorts of things here. So the Snowflake connector for Python is a really popular way of connecting to your Snowflake environment and communicating with SQL in your Python client code. The second really popular way of using Python with Snowflake is through Snowpark. So Snowpark is Snowflake's data frame API for performing all sorts of transformations against your data in either Python, Java, or Scala, and all of the compute is pushed down to Snowflake. And while yes, you can execute SQL from your Snowpark session, a lot of what you're going to be doing is loading your data into data frames and performing whatever transformations you might need to perform against that data, and then saving that data as tables or creating views as an example. Now, there are other things that you can do with Snowpark for Python, but this is another really popular way of using Python against your Snowflake data today. But the Snowflake Python APIs are completely different from the Snowflake Python connector and Snowpark for Python, primarily because it is a first-class way of programmatically managing Snowflake objects fully in Python. So you won't be needing to execute SQL queries from your Python client code. You can just write Python code declaratively to manage Snowflake objects. What I like about this page in the documentation is this diagram where you can see how in the snowflake.core library, as part of the overall Snowflake Python API library, we expose several different APIs for managing databases, tasks, tables, and a few other Snowflake objects here. And just a quick note before we dive into the demo, you don't necessarily have to use one of these methods or tools over another. You can absolutely use them together if your use case calls for it. You could, for example, establish your session or your connection to Snowflake using the Python connector. You can perform your transformations using Snowpark for Python, and then you might use the Snowflake Python APIs to manage, say, something like Snowpark Container Services. So that's a brief primer on the most popular ways of using Python with Snowflake today. Let's go ahead and dive into the demo. All right, so before we get into the demo, let me quickly explain what we're going to do. We're going to use the Snowflake Python APIs to spin up a Snowpark container, and inside that container, we'll run a service that runs a very basic Python Flask app that contains logic to convert temperatures from Celsius to Fahrenheit. Now, the point of this demo is not to necessarily demonstrate anything extremely complex running inside of the container, but what is neat is how easy it is to run a Flask app directly in my Snowflake environment. What I want you to focus on is how I'll be using the Snowflake Python APIs to programmatically manage all aspects of this workflow. And again, I'll be doing this from inside of a Snowflake notebook. So let's go ahead and get started. Okay, so the first thing that I'll do is some basic account level setup. And I'll use the Snowflake Python APIs to create all the objects within my Snowflake account that I'll use for the rest of the demo. So in this cell, you can see that I'm importing from the snowflake.core module inside of the overall Snowflake package. And I'm importing a few things here that I mentioned are organized under snowflake.core, specifically root, warehouse, and then some bulk imports here on line 7 and line 13. And these imports are going to allow me to use the APIs for several different object types in my account. All right, so next here, I create my session, and I'm assuming the role of account admin, and quickly take a note at what's happening here on line 27. This is arguably one of the most important lines of code in this cell. So I'm creating a root object by invoking the root class, and I'm passing in my session as an argument. And the reason that this is important is because all subsequent API calls and declarations are going to happen by invoking this root object. And so you can see here on line 31, I'm creating a role called container user role. And I'm doing this by calling root.roles.create. And then I created this role by passing in a role object with the name of the role, in this case called container user role. And here's a quick comment that describes role. And then last but not least, I specify a mode for how this role should be created. So you can see it here as create mode or replace. And what I've done in this cell as a comment on line 30 is show you what the equivalent SQL would look like if you were to run this SQL in your Snowflake environment. And so after this, the pattern is very similar for different aspects. So here you can see I'm performing all sorts of grants for this role. And you can check out the documentation for exactly how to invoke the Python APIs for different objects. And then now I'll show here how I've created a database and a warehouse. So here's the database, here's a warehouse. And I'll spend a little more time here on line 87 so you can see how I'm creating a warehouse. So again, similar pattern, root.warehouses.create. I specify the name, the size of the virtual warehouse, the auto suspend and auto resume policy, as well as the quick comment, and then the create mode here is create or replace. So like I said, similar pattern as before. And the last thing that I'll show here is how I'm creating stages using the Python API. So you can see here, I create a couple of stages, and I do this first by referencing the database and the schema where I want to create the stage. Then I invoke the create function and then specify the details of the stage. And we're going to use these stages for a couple of different things in the later part of the demo. So I'm going to scroll up here really quickly and click on the run icon. In subsequent cells, I'll just go ahead and do the hotkey of command return, but I'm just going to run this cell only. And if I scroll down, you'll see that all these objects were successfully created. Great. So now that we've done our account level setup, let's move on to setting up Snowpark Container Services. Okay, so on the left, now you'll see that I have the objects that I created using the Python APIs. So a database, a schema, and some stages here. So let's now create some of the objects that we're going to need to run Snowpark Container Services. And we'll specifically create a compute pool and an image repository in my Snowflake account. And this repository will hold the image that we're going to run inside the container. So again, I'm going to be using the Python APIs to do this. And here at the very top, you can see that I'm importing the corresponding APIs, the compute pool, image repository. I'm assuming the account admin role. And then down here, I'm going to be assuming the container user role and using this warehouse. And then I'm going to go ahead and create my compute pool here. So root.computepools.create. I specify here the name of the compute pool, the min and max number of nodes, the instance family. In this case, this is a CPU-based instance family of the smallest type. And the mode is or replace. And then down here on line 63, I'm creating the image repository that will contain, again, the image that will run in the container. And I'm doing this in a similar way to how we created stages earlier. So here, root.database.schema, so referencing the database and schema where the image repository will live. And I'll pass in the details of the image repo there. And then down here, just as a sanity check, I quickly write some code that prints out the image repositories that are in that schema. So let me go ahead and run this cell. All right, great. And so now you can see down here, I'm printing out the image repositories, and I get something that looks like a memory address. So it's saying, hey, I do have this object at this address. Okay, great. So let's move on to the next step so that we can get closer to deploying our Flask API inside of a container. All right, so now on the left, you'll see that I have this image repo that we created using the Python APIs. And this is going to be the image repo that will hold the image that will run in our Snowpark container. So I quickly want to run this one cell here that's going to show me a little more information about the image repo. So if I run this, what I want to highlight here is this repository URL. So there's a repository URL that's associated with all Snowflake image repos. And this allows you to programmatically push container images up to this repo, say from the command line. So what I'm going to show in this step is how to build our container image using the Docker CLI. And then we'll push that image into this repository also using the Docker CLI. Now, before I do that, let me just quickly orient you into what exactly we're pushing up. So I mentioned earlier that we're going to be deploying a very simple Flask app. In this case, it's actually a REST API that we're creating with Flask. So if I navigate over to the source code, which again you can find linked in the description to the video, you'll see a couple things. You'll see that I have a convertapp.py file, which contains my very small API. There's a function here that converts Celsius to Fahrenheit. And then there's a single route that I defined called convert. And essentially when that route is hit, it'll attempt to convert the data in the request payload, assuming that it contains temperature data, from Celsius to Fahrenheit, and then return that converted data. And then so here is the Docker file where we reference convertapp.py as a Flask app. And so the first thing that we'll do from the command line is use the Docker CLI to build the image. So I'll go ahead and run this command. All right, so it's been built. The next thing that we'll do is we will log into the repo so that we can push the image into it. So I'll go ahead and just run this command. This is going to prompt me for my password. It's just the credentials that I have for this Snowflake environment. So I'll go ahead and type in my password. All right, so you can see that I am successfully logged in. The next thing that I'll do is tag the image. So I have this command here, been tagged. And then last but not least, I'm actually going to push this image up into that repo with this command here. All right, so this is going to take a few seconds. So just give it a little bit of time to run. You can see that it is pushing up the image. And once this is pushed up, then we can start using the service within our Snowflake environment. And I'll show you how to do that from the notebook that we have. All right, so now with the image pushed up, I can now start using the service. All right, so with the image pushed up, let's go ahead and start using the service. And so in this cell here called REST service, what we'll do is use a Python API to create the service. So first, what we do is assume the correct role. And then here on line 30, I create the service. And I do this by calling services.create on the corresponding database and schema. And then I pass in some information around the service. So the name of the service, the compute pool that the service will run on top of, and that's the compute pool that we defined earlier. And then on line 33, I am passing in the spec for the service definition. And that's just a YAML file that I have in this specs stage here. Now I'll show you what that looks like in just a bit. But this is essentially how I'm creating my service. So if I show you what the service definition looks like, it is this convert-API YAML file, which contains the name of the container and then a path to the image. And then you can see here in this other tab that I simply uploaded this file into the specs stage. And so that is how the service knows where to look for that YAML file. All right, and then I quickly grab a reference to the service, and I'm going to use this in a later part of the cell. And if I scroll down, you'll see here on line 58, I'm creating a table called weather that has these columns. And that's where we're going to store some sample data to use against the API that is running in our service. And then next, I create a UDF that references the logic that we defined as part of the convert route in the Flask API. And so then now what I do at the very end here is insert some sample values into the table, and we'll send this as part of the request payload and use the UDF to convert this to Fahrenheit. So this is basically the workflow for creating the service. So just to quickly recap what I did, I created the service specifying the compute pool and the location of the service definition, which is a YAML file that lives in a stage. I created a table that contains some sample data that's going to be passed to the route in our API. And then I created a UDF that references the logic that's in the convert route. All right, so I'll go ahead and run this. All right, and so you can see that this successfully ran. And so now with this created, we can now execute the service. All right, so now I'll go ahead and execute the service, and I'll do this by running the UDF that we defined earlier, again, using the Python APIs. And the way that I'm doing this is just by calling .functions, again, on the corresponding database and schema. I reference the name of our UDF here, and then I execute this. All right, so let's just go ahead and run the UDF against the sample data that we inserted. And so if this is successful, again, that sample data is going to be used in that UDF that references the logic that's defined in the convert route that is part of the Flask API. So just give it a few seconds here to run. And if all goes well, you should see some output that converts the temperature from Celsius to Fahrenheit. And so you can see this. You can see the conversions for several different rows that we inserted for different cities. And so we went ahead and used a service that was running in our Snowpark container. Awesome. So let's quickly recap what we did. The first thing that we did is we did some account level setup using the Snowflake Python APIs to kind of just set up our databases and schemas and corresponding objects. We then set up Snowpark Container Services, including the compute pool that we would run our service on top of. We went ahead and pushed our container image up into the image repo. We added the spec YAML file into the spec stage. And then we made sure to reference all of that in the service definition using the Python APIs. Then finally, we actually execute our service here and use it to convert some information. And this all happened within my Snowflake notebook and using Snowpark Container Services programmatically, entirely in Python. So thank you so much for following along in this demo. If you want to explore this notebook, I will be sharing the source code in the description to this video. And you can also find all the source code that I used in this demo also in the description. So thanks again for following along, and I'll see you next time.